Last week, I did a video on what was the concepts behind an eclipse. This week, we're going to answer some questions that some of the audience member have mentioned. Also, share about how scientists are looking for new discoveries for the eclipse happening. I had an excellent question regarding what is happening at the eclipse. Is it going to be only total eclipse for some and then no eclipse for others, or is there a variation? So that is the excellent question. So here I live in Eastern Canada, and I'll be able to watch a full eclipse. So last week I mentioned that here's the path of total eclipse here with the dashed line on the map. So this map, by the way, is from Time and Date website. And that's the best one I've seen for this part today. So if you look at the map, you will notice that you have here 100% total eclipse on the path of the moon. You will also notice that they have some different shades going to the orange, yellow, and then white segments. And the reason for that is that if you are on the path of the eclipse, then you'll have a total eclipse. However, if you are a little bit south of the path or a bit north, what will happen is that you will see an eclipse, but it will not be a total eclipse with 100% of the sun being hidden. It will actually be an eclipse where with what we call a partial eclipse. That means that you might see maybe 90%. So if you're here on these orangey color, you may have 90 to 95% of the sun being covered, but you still have some sun. If you go here in northern Quebec, here in the middle of the United States, and here if you go in the southern part of Mexico, you will notice that you have maybe 50% of the sun to be covered. And here, the further north you go, the percentage goes down. So if you live in Alaska, you won't have any eclipse at all. If you live in Venezuela, Colombia, or Peru, you will not notice an eclipse at all. And the reason for that is if you're too far away from the path of the eclipse. So here, I'm in Eastern Canada here. So what will happen? I will be in a situation on the path where I will see the sun will come, will start covering the sun. And from what my understanding is 5 to 7 minutes, and the sun will come back. And then that is what it will be. For others, it will be the moon as if it's touching the edges of the sun, and that's why it will be a partial eclipse. Now, keeping in mind that we had a few eclipses in the last bit, so here, this is what we had in October. So in October, we had a solar eclipse, but we had what we call the Ring of Fire eclipse. And the reason for that is that you had here the moon between Earth and the sun, but it was just a little bit away from us. So what happened is that the moon was hiding the sun, but it was not close enough to us to cover the entirety of the sun. Hence, a Ring of Fire eclipse in October 2023. And we will have this year on the path to a full total eclipse. So there we go. So as you can see, that's another excellent picture. It shows us that you will have a place where you'll see the sun and it will be totally covered, and then you'll see the sun again. Now, keep in mind that if you're watching the sun, you have to be very careful. So I'm gonna see if I can remember to put a link here of the video from last week, or have a look. It's amazing. I explain how it can affect your eyes. So I do hope that if you have a chance, you've had a chance to get yourself some glasses so that you can watch the sun. Even though these are supposed to be excellent, I will not look at the sun for 20 minutes in a row. I will look at the sun and look sideways. And the reason for that is that even though these glasses are most likely excellent, I still want to be careful with my eyes. You will also notice that when you look in the sky during the day, the sun seems fairly big, and there's some diffraction, a refraction of the light in the atmosphere. When you look with your glasses, you will notice that the sun appears very, very small, and that is normal. Was this one here? So as you can see here, we have the sun, and the sun will be covered by the moon. You can see it's progressively being covered, and then it will come back on. Keep in mind that the sun will move on the sky during that time. So there's a lot of things happening. It's all happening in 3D. Here we have an example of, as I mentioned, and sorry for not putting this earlier, the moon covering 100% of the sun will allow us to see what's happening on the outer edge here of the aura of the sun, and that will be exciting. And this one here, so here's an example of a partial eclipse where the sun will cover the sun partially, but you'll still see light. So usually it will be a feeling of what we see in the evening or in the morning, when you could see that at dawn and dusk there's some light there, but not too much. Some of you will say, well, how can you get a sun this big on pictures? Don't forget that you've got scientists that are taking pictures with amazing cameras that are very far from what we can get with our phone. And there we go. So here is what we will see. Let's see if I can look at something else. What is the other thing I wanted to say? Let's see. Okay, so what are the different things scientists will look for in the coming days? First of all, we had here, let's see if I can get this one. Perfect. So there's a zoo in Quebec, and what they will do is that since we have a full eclipse, they will want to look at the behaviors of different animals when we have an eclipse. Now, keep in mind that when you have an eclipse, for example, it is a time when animals will say, okay, the sun is setting down. Let's see if I can either wake up, either go to bed, or either start feeding. So there's a lot of things, that behaviors that come from the niche of that, the footprint of that animal in the environment. Now, what is interesting with this one is that we have an eclipse that will last a much shorter time. And the whole idea here is, how will this affect animals? And so usually, so they say that an eclipse, a full eclipse that will happen the same way at the same place, will happen in maybe 300 years. And knowing that we cannot move zoos and animals easily, being able to see the way animals behave will be amazing. So here, here's a great example where the moon is between us and the sun, and us being able to see the corona here of the sun. And here are some of the animals that they are going to look into. So here we have the small panda here in French. They're called the little pandas. There you go. We have the snow leopard. We have Japanese monkey. I don't know how they call them in English. In French, they're called macaque. And we have the ostriches. What is happening here is that they will have a look at these animals. And they have about a dozen of them where they will observe what is happening with them. So keep in mind that it's a big change, a big shift in the environment, to be out of their control, and it will be interesting to see what it will be. So scientists will not be looking at the sun, but they will be looking at what's happening on Earth. If you look at the social media, there's a lot of stories going out there. Some people are panicking. Some people don't want to look at the sun. For schools, some people want to keep the students inside. Some schools have closed for that day. There's so many stories going around. The main thing is to make sure that regardless of what you do, you are being safe. And I have some glasses that I will do. And from last week's video, I also mentioned that you can use a box to see the sun. And that's a good way for you. If you look at the reflection of the sun, it's the safest way compared to looking at the sun directly. Perfect. What else will the scientists look into? So here, if you have the atmosphere, so here at the bottom here, you can see, I don't know if I can make it a bit bigger. We have a section here that we have a place where we live. So we live and breathe. We have the level where flight is happening. But here at about, I don't know, maybe 100 kilometers to about 600 kilometers, we have what we have, the thermosphere. That's a place where there's a change in temperature from temperature in space compared to what's happening on Earth. And a lot of things are happening here because this part of the atmosphere, called the ionosphere, is always in contact with solar wind. So it's called the ionosphere because there's a lot of ions in this area. An ion is a particle that has a charge. So when you have the solar rays coming into the ionosphere, it will take some molecules and it will break them apart, given the quantity of energy given to them. So a lot of scientists will go and study that. Either they will have planes following the path of the eclipse, they will send sensor in the atmosphere. Because the ionosphere, interestingly enough, you have a place where it reflects some of the waves, like radio waves on the planet. For GPS, for example, coming from the ground, you also have communication satellite and GPS satellites that are sending information down to us. So there's a lot of things going on here, and the ionosphere is part of that ecosystem. But if you look at the layers, so here so I found this drawing, it was quite amazing. So during the day, we have the sun that is sending us light and energy. But in the solar wind, you also have the particles that are working within the ionosphere and are breaking down some molecules, given the energy. Now, when you go at night, this energy is no longer there. Those ions lose their energy due to the coldness of space, and then they reform their molecules. And then 12 hours later or so, then the cycle comes back again and again. However, scientists will look at what happens if the moon comes between the sun and Earth, so that momentarily, in a specific space, given a specific time within a few minutes, we will be able to see what is the effect of not having sunlight on the ionosphere, and then they will be able to pinpoint what it is. That will be quite exciting. So good. There's something else I wanted to talk about that. Oh yes. I had another question about this map right here, and the map was, how come we have a total solar eclipse starting right in the middle of the Pacific, and it ends right in the Atlantic? Now you have to keep in mind that we have total eclipse maybe every 18, 20 months. So they happen often. However, they often happens in the over the ocean or over areas that is very hard to have access. And that's the reason why we think this is quite a great way. Now, interestingly enough, if you have, so I'm going to take the globe here to show you. So if you have Earth like this, and you have the moon that is orbiting, so let's assume that my cup is the moon. The orbit, sometimes it goes diagonally like this, sometimes it's along the plane, sometimes it's the other way around, depending on where the moon is on the orbit around the planet, and depending on the season. Now you have to keep in mind that if I have the moon, regardless if it is in front of the planet or above it or under it, will always have a shadow. The shadow is always on the dark side here, and I can see here when no light is coming through this cup. So the whole idea of shadows, it exists all the time. However, to be able to have that shadow right on the planet where humans are, where we can study it nicely, is not necessarily easy. The next question, why it is starting at some point here and ending on the Atlantic. And here we have, look at this, it's just like in Europe, France and Spain will miss this activity. It's because we are working in 3 dimensions. So here we have, so if we have our globe here, we have Europe right here. So when you have, let's say, 7:30 in the morning, we have here maybe 3:30 in the morning here, maybe even earlier. So what happened here, you have the morning, we have the night here. As the day progresses, then you get to the evening here, and then here we are in mid-morning or maybe noon. So what happened is a difference in time. So that's the first thing. The next one here is we have here our eclipse that will start here, follow in North America, and go this way. So let's see. Let's assume that you are the audience, the sun. Like this, perfect. You are the sun, and I have coffee in my cup, so I have to be careful. If I have here my cup will create a shadow on here, on my planet. So I'm going to go like this, keeping in mind that we have this the moon that will go across like this, and we'll move on this way. So if it happens that we are here, that is excellent. Then we have here the moon that will go across. There's a few things happening. The moon does travel fairly fast. So it travels fairly fast. It's going to go up this way. But on top of that, we have the Earth that will be turning this way and having a rotation this way. So what happened is as we have the orbit going up this way, we have an Earth going down this way. So when it happens for us between 1 and 4 in the afternoon, it will be something like from 6 o'clock p.m. to 10 p.m. your time. Oops. So what happens by the time in Europe it is 10 p.m., there's no sun left. So what happens is that we have a visible eclipse, but here it will be the night by the time the eclipse gets there. So this is why we are seeing those. Interestingly enough, if you like geometry, with the geometry here, it will be more like an elliptical, let's see, shadow that we have here. Right in the middle, we have shadows that will be very pinpoint, like a circle, and here will be more of an ellipse. So what is going on here is that we have to think of geometry where the Earth is rotating on itself, we have the moon orbiting the Earth, and we have the Earth rotating on itself. So there's a lot of things going on, and in 3D, it will happen very fast. And these are the different parts that I wanted to share with you with respect to what scientists will be looking at for this. Oh, did I show it? Yeah. Very nice. Good. So this is what I think is exciting. This is what the scientists will be looking for. Looking at the sun just for the sake of an eclipse is exciting, but the science behind that will be very good as well. So all kind of topics I brought today. If it happens you have any clarification questions, put them in the comments below. I'm here to answer your questions, and hope if you have a chance, don't hesitate to subscribe to our channel, as we are creating science video every week, and I do that for you. And you always give me excellent questions where I need to do some research, because I love to learn as well. On this, if you have a chance, I'm going to put here, let's see if I can end this one. I'm going to put here a link to the video I did last week on the basics of an eclipse, and I will see you there. You'll see lots to learn all the time.